Elon Musk's vision of an ultra-affordable Tesla priced at just $10,175 has sparked both excitement and skepticism. Many critics label it as another overhyped concept destined for delays and disappointment, citing past examples like the Cybertruck and Tesla's long-promised $25,000 vehicle. But this time, a confluence of leaked factory plans, cryptic tweets, strategic battery developments, and factory timelines hint that Tesla might actually be closer than ever to launching this groundbreaking EV, possibly named the Model 2. The whispers are growing louder, and now the pieces seem to align toward a real 2026 debut. What's unfolding appears to be far more than just talk. It could mark the single biggest disruption in the global automotive landscape. Since the original Model S, a major hint came when Elon Musk discussed progress at Giga Factory Mexico. Without naming the model to outright, Musk emphasized Tesla's strategy of delivering the best product at the most competitive price, indicating that cheaper models are in the works. He also acknowledged potential bumps along the road, but reaffirmed Tesla's commitment to expanding access to electric vehicles. The planned start of production in June and a timeline that aligns with current construction progress suggest that Tesla is paving the way for a new generation of affordable EV. Adding credibility to this vision, Tesla engineers have been actively filing patents since 2024, revealing critical innovations like modular chassis layouts, structural battery packs, and simplified body frames. These aren't mere upgrades. They indicate a fundamental redesign geared toward slashing production costs and enabling mass scalability. To sell a car for just over $10,000 and remain profitable, Tesla must scale to unprecedented levels. Internal forecasts suggest production goals of 4 million units annually for the Model 2, more than double Tesla's current total output. This volume requires an entirely new manufacturing philosophy, which Tesla is already building: the unboxed production method. Rather than following the traditional linear assembly line, Tesla's new approach builds 4 key sections of the vehicle: front, rear, battery, and cabin in parallel, drastically reducing assembly time. These sections only come together in a final unifying step, eliminating wasted motion and increasing throughput. Tesla believes this will cut production time per unit by 75% compared to current lines. While the unboxed method isn't being retrofitted across the company, it's being purpose-built for the Model 2, reinforcing the idea that this vehicle is designed from scratch for affordability and scale. The timeline also makes sense when considering construction progress at Gigafactory Mexico, which broke ground in early 2024. Phase 1 is expected to be completed by late 2025, with full-scale production possible by early 2026. The factory isn't the only facility gearing up. Battery production at Panasonic's new Kansas plant is expected to provide 30 gigawatt-hours annually, starting in 2026. Simultaneously, Tesla's battery operations in Austin and Nevada are expanding to meet projected demand. Meanwhile, regulatory filings surfaced in early 2025, referencing a new compact EV not currently part of Tesla's lineup. These were filed in both North America and Europe and quietly mentioned crash test preparation for a vehicle in the compact class. While each piece of evidence might be ambiguous on its own, together they build a strong case. Tesla is preparing to mass-produce the Model 2 using proprietary technology, new battery chemistry, and manufacturing breakthroughs, all by 2026 design-wise. The $10,175 Model 2 promises to be no ordinary budget EV. The body is expected to be built with a single-piece casting process that Tesla pioneered on the Model Y's rear chassis and the Cybertruck's frame. This gigapress-based approach cuts the number of structural components from hundreds to just a handful, reducing assembly complexity and cost while improving structural integrity. Tesla's 9,002 gigapress machines enable these massive castings, making the car simpler to produce, stronger, and faster to assemble. Combined with a 20% reduction in production time, the result is an EV that's both efficient and financially viable at the sub-$11,000 mark. Aerodynamics will also be a quiet game-changer. Supplier leaks and wind tunnel tests indicate Tesla is aiming for a drag coefficient of just 0.21, better than the Model 3's 0.23 and rivaling ultra-premium EVs Like the Mercedes EQS, better aerodynamics mean greater range using less energy, which in turn allows for a smaller, lighter, and cheaper battery without compromising performance. A sleeker, smoother exterior will also help keep production costs down. Expect the same Tesla minimalist aesthetic: a clean, badgeless front, flush door handles, frameless windows, and precision paneling that emphasizes both form and function. Sustainability is also being woven into every inch of the vehicle's design. Tesla's commitment to animal-free interiors will carry over with vegan leather seats and steering wheels. Recycled plastics will likely be used for dashboards, door panels, and center consoles, while plant-based foams might replace traditional petroleum-based materials in seats and armrests. Altogether, the interior could be up to 70% renewable or low impact. Tesla is also expected to use modular seat rails and folding seatbacks to offer flexible cargo configurations, an essential feature for urban users who need to adapt the car quickly for passengers or storage. In terms of technology, the Model 2 could be unmatched in its class. It's expected to come standard with Tesla Vision, the camera-only driver assistance platform trained on over 10 billion miles of real-world data. As a result, the car should offer smarter and safer driving support out of the box, continuously improved via over-the-air software updates. In 2023 alone, Tesla pushed over 50 global updates, many of which added new functionality to older cars. That tradition will continue with the Model 2, meaning buyers will get more value over time without buying new hardware. Tesla's app-based experience is likely to be fully integrated from the start. From unlocking the car to adjusting settings or preconditioning the interior, nearly all functions will be accessible via smartphone. This software ecosystem, which already enjoys a 90% plus adoption rate among existing Tesla owners, is only growing, adding new tools and services by the month. For the Model 2, it becomes another way to lower complexity and eliminate physical interfaces, which translates to both lower costs and a smoother user experience. Making a car this advanced at this price also requires revolutionary battery design. The Model 2 is expected to debut a new variation of Tesla's 4680 cell, dubbed the Gen 2. This updated version is slightly shorter, 70 mm tall versus 80 mm in previous designs, allowing tighter energy packing, better thermal control, and enhanced structural rigidity. These new batteries make it possible to install a flat structural battery pack into the car's floor, improving center of gravity and cabin space. Tesla aims to achieve over 400 miles of range using this smaller and cheaper powertrain, again proving that low cost doesn't mean low performance. The modular, robotic, unboxed production process is also essential. Tesla has developed robotic cells with partners like Grumman Automation and Kuka, enabling the front, rear, battery, and cabin to be assembled independently and simultaneously. Each robotic cell handles everything from welding to painting, leading to up to 50% lower costs and 40% smaller factories compared to traditional auto manufacturing. Because Tesla controls both the software and the hardware of the entire system, it can optimize everything. End-to-end battery design affects body shape, which affects airflow, which affects software performance. Tesla's hardware autonomy is also expected to get a boost. The Model 2 could debut Tesla's full self-driving FSD hardware 5.0, featuring faster processors, better cameras, and improved cooling. These enhancements won't just provide better autonomous features at launch, they'll ensure the car stays software upgradable for years to come. In a $10,000 car, that's unprecedented. Where most entry-level cars stagnate technologically, the Model 2 may improve month after month. Performance will surprise even more skeptics. Despite its price, early data suggests a 0 to 60 miles per hour time of around 6.5 seconds quicker than a Honda Civic, Toyota Camry, or base BMW 3 Series. That level of performance puts it in the same category as cars, 2 or 3 times the price, making the Model 2 not only affordable but exciting to drive. Top speed will likely be electronically capped, around 120 miles per hour, which is more than adequate for most driving conditions. The car is expected to come in a rear-wheel drive single-motor configuration for maximum efficiency and minimum cost. Tesla's V4 supercharging system will also benefit Model 2 owners. With charging speeds exceeding 250 kilowatts, the Model 2 could charge from 10% to 80% in just 20 minutes, making it viable for long-distance travel despite its compact form. Efficiency is also likely to be industry-leading, with over 5 miles per kilowatt-hour expected, surpassing the Model 3's current 4.2 miles kWh. That means lower energy costs and more miles per charge, all with a lighter and cheaper battery. To support real-world use, especially in colder climates, the Model 2 is expected to include a standard heat pump. This system significantly improves winter range compared to older resistive heaters, many of which are still used in competing budget EVs. Tesla already includes heat pumps in the Model Y, and bringing this feature to the entry-level Model 2 would be a game changer for usability across all seasons.